We had to grow. We were 100% maxing out every machine. When we first took over the space, this was disgusting.
I literally got the forklift stuck in fermented grease that's been setting in the Texas heat.
In general, we're an advanced engineering and manufacturing company, so we're designing and building primarily aerospace and defense. And the machine shop, at some level, is the backbone of all those projects. Originally, we took one more bay over in the building and we turned that to machine shop, and it was nice. But then we basically stuffed every machine we possibly could in there, and it was like, you know, kind of like, excuse me, pardon me, to get by every time. There was no way we could get any more machines in there. So it was kind of like self-evident. Any amount of growth at all would require us to take on more space. The space next door, which was basically the remainder of the building, became available. So we jumped all over that.
Okay, so this is gonna be, we just took over, we just signed the lease. So this is gonna be the new machine shop. So currently, on the other side of that wall is our machine shop. We're doubling the size of our machine shop, and then the machine shop will end up being assembly. And then this looks disastrous right now.
The space was kind of disgusting.
Well, before, there was a company that cleaned and collected fryer grease. So it smells like kind of fermented fryer grease in here, which is a really nice smell. It was like, I literally got the forklift stuck in fermented grease.
Getting the space was straightforward, but then we had quite a bit of construction work to get it ready for what we needed.
We got to make a ramp because it's on a loading dock. We got to run cable trays for all the power and air. Really elevating the game of the machine shop quite a bit. So it's a lot of work to do, but pretty excited.
Well, I mean, we always want, like, if we're going to do it, let's do it right. So I've had this vision of what, you know, our machine shop would look like in the future. So we took some huge strides in that direction. So we also bought a couple bigger machines that required foundations to be installed. So first thing we did was cut giant holes in the concrete and dig really deep foundations for those.
All right, concrete has been placed. Got the block outs here. So those will be for the anchor bolts for the lathe.
I wanted the walls to be nice. It's, you know, it's a steel building, so you just kind of look at the back of the insulation, which is pretty tacky. So we framed and drywalled the interior walls.
New machine shop. Starting to look like something. Getting a lot of the conduit runs done. And we still got to put a door into this wall here pretty soon. All right, first coat of primers in. AC's getting put in. Hell yeah.
It was quite, I mean, it was its own construction project onto its own. So it looks easier in hindsight than it was in execution. And I have for a decade wanted epoxy coated floors in a machine shop. So once we did that, it was like, oh yeah, this is for real. And it definitely makes a huge difference on the way that it feels. And then obviously the way, you know, our customers see it and vendors see it, that they can tell that, like, yeah, we care at a pretty deep level about the details. The logistics of moving the machines is always challenging. Working through those little kinks of, you know, what basically was, for all intents and purposes, a new shop building. It's going to have its like little things here and there. It's just like 10,000 little things. There wasn't any one particular one that was overly painful.
So this, I guess this is the new space here. So we laid it out in SolidWorks and checked that, you know, all the different carts and pallet jacks and everything can easily access everywhere we go. We put a lot more thought into where people's offices are, you know, where they're gonna program parts, so that they have a little better setup there instead of just being kind of thrown in the middle. It's Texas and it's like hot as hell, so we put like a 50% bigger than we need air conditioner so that there will be no complaining by the machinists this year, I hope. We're gonna find out. So this guy here was our OG. We bought this like 6 years ago, bought it used. It was kind of when we were first getting started here, but it's a workhorse. It's nothing fancy, but man, this thing runs every single day, every hour.
I would call it like an entry-level machine, but it's literally works 10, 12 hours every day. We run some production jobs on that. You know, you take care of it, it's going to take care of you. So it can't do really big parts, but it's simple to use. There's a lot of people that can operate Haas, so it's still a great machine to have in the shop.
We take care of it, do a lot of maintenance, but it's a workhorse, not very big, but she does the job. Over here we got the VF3 SSYT. So this is a good size machine. We can do a lot of plate work on this.
It's a super speed machine, so it can spin higher RPMs, which is great for high speed machining of aluminum.
It's also got an extended Y-axis travel, and then we can put a 5-axis trunnion on here.
So because it's a trunnion on a regular 3-axis bed, we can do plate work or vice work on that as well, or we can do like complete parts. So it's actually a really convenient setup to do all operations required on complex 5-axis parts. So we use that kind of nonstop. It's another workhorse for us. We do take the trunnion in and out as needed. Sometimes we need a little more bed space, which is another nice reason to have a trunnion type machine.
And over here, we got 2 different VF4 SSs. So these are kind of like the standard machines that we're going to run a lot of our parts on. So, you know, anything like the bigger pieces like this, these are pretty simple. Bigger pieces, or if we want to set up a bunch of vices and run a bunch of parts at once, vacuum plates, other fixture plates, sub plates, we can use. These are good enough, big enough size machines that works well for us.
They're both super speed machines, so we get that higher RPM. Those are kind of the bread and butter machines. We could do, you know, multiple parts or multiple operations with one door close.
And we set them up so one operator can do both machines back to back. And then, you know, both workbenches are set up identical. So if you walk up to one, this one's a little bit newer, but they're basically the same. So it has a carbon fiber cover, makes it fancier looking, but for all intents and purposes, they're identical. And then we even set up the workstations identical. So every workstation is that way. So, you know, any operator can step up and feel at home.
Some of the recent upgrades we've added was a Mazak VC Easy 20X.
So this is a 5-axis or 5-axis mill. So this is where we kind of stepped up. We got a much bigger machine. We're able to do a lot bigger parts, 5-axis now. This was one we had to put a really deep foundation in for. Still finalizing the like seal around the foundation because this needed to be isolated from the rest of the building for some reason.
With the Mazak, we're getting, you know, a lot more precision, some of those fancier features to do some of the fancier aerospace parts that we get into, that's able to do those in, you know, a single or 2 operations with a 20-inch work envelope. So it's a pretty big envelope for a 5-axis. So that's been a big addition to our capabilities.
But we're real excited about this. And then over here, we got 2 of our lathes. So we have kind of the old SL10 Haas lathe, small little lathe, but it runs parts all day for us. It's a great little fighter in the corner. And then we got this year the Mazak Quick Turn 250 MY. We can do mill turn parts on this with live axis tooling. And this is kind of a big step up in terms of the sophistication of what we can do in one op. So before we used to have to turn a part and then take it over to one of the mills to do secondary ops, whereas we're able to do everything in one go now. So that's a pretty big improvement. And then it's got bigger size, so we can do a bigger part on this. So
it allows us to not only do better parts and more, you know, when I say better, like tighter tolerance, but it lets us do them with fewer operations than we would have previously had to do. So it's a big increase in both speed and precision, which is cool.
Then we still have some extra. We obviously over here we got the, you know, the old Bridgeport and the manual lathe that will do kind of secondary ops or even some sort of prep ops on those. Every machine shop's going to have that. And then we still have a little bit of space left over. So for future growth, we can add a couple more machines here we have room for. And then the door, we've got it set up. So again, we keep our inventory pretty tight so that when it hits there, it should run to a machine real quick and get out the door in a hurry.
We're kind of on the market now to see what the next machine will be. So we're kind of scratching our head thinking of like, what do we add now? What are we missing? What would we add to add some capabilities?
A lot of shops would take that excess space and make a bunch of racks and probably shelving for a bunch of extra tools or material they need. Whereas we kind of do the opposite. We minimize that space, minimize inventory, minimize WIP, keeps everything running a lot more efficiently.
I think the machine shop, we just want to keep growing in sophistication and capability. I get entertained by the projects that require more complicated parts. And then as a business, just kind of that same concept of more complex, more of the engineering intensive, planning intensive jobs, pushing the envelope of technology.
I'm excited for what we're able to produce now in terms of throughput and complexity.
This is American Precision Engineering. We make the stuff that makes the stuff.